This is a refraction tank. It will show us how light refracts as it goes into the water, and will also allow us to see something here in a second called total internal reflection. First of all, just so that you get an idea what's happening, we have a green laser here. We also have a refraction tank. Notice that there's water, half full, so that it's at that line. And we have a small piece of glass or plastic that's going to spread out the light. Otherwise it would be a point source and you wouldn't really be able to see it. Let's go ahead and turn off the lights. It'll make this a lot easier. Lights off. If I put this straight in so that it's going straight down, the theta, because it's measured from the normal straight up and down, is 0, and the sine of theta, sine of 0, is 0. So if it goes straight in, it goes straight through. Also, if you want to think about the idea of something like people running on the beach, both sides hit at the same time, so it doesn't refract. It doesn't have to bend. Let me move it. Notice at this point, the side towards my right hits first, slows down. The upper part of the light takes an extra step, if you want to use that analogy, and it bends toward the normal. In this case, my angle is 60 degrees because the angle is from the straight up and down, the normal, perpendicular to surface, not from the surface. Notice it is bent toward the normal. No matter what I do as I go from fast to slow, it will bend toward the normal. Now you'll also notice here that some of it has reflected off of the surface. Whenever a wave switches mediums or transverses mediums, some of it is reflected and some of it transmits and some of it is reflected. Now let's go underneath. Sorry, let's go turn off the light here for a second. Now I'm underneath, and notice that it's bouncing back. This is known as total internal reflection. Why total internal reflection? Because remember, some of it reflects when you're going from the top as well. And if I get far enough down, sorry about the squeaking, notice that it's going through. The angle in air, the fast medium, is greater than the angle in the slow medium. But because the angle in the fast medium is greater, at some point, if I keep going, it hits 90 degrees and will reflect back. That point at which it hits 90 degrees, which is somewhere right in there, is known as the critical angle. Now we're going to try this not just with water. I'm going to go ahead and switch to a different medium. Don't turn it off. Okay. Because I know that it's dark now. Okay, in this case now, I'm using the laser, I guess, as my light source. Now I have a different medium. I have an acrylic of some sort, and notice it's round on the bottom and flat on the top. And there's its total internal reflection again. And you can see somewhere in there, when I keep going down, oh, now it's coming out, shining up on my body. There you can see it. Now, boom, now it's inside. And if I go straight in, it comes straight out. Critical angle is somewhere in that area where it switches from going through to reflecting back. And there you can see total internal reflection.